Okay, next up we've got Ralph Haferkamp, who's going to be talking about Kata Containers on openSUSE.
Yeah, hello and welcome. Nice to see so many folks here. My name is Ralph Haferkamp. I'm working at SUSE. I recently joined the Containers core team there, and I've brought with me Dario Fagioli. He's working on the virtualization team at SUSE, and together we are talking about Kata containers and what we are doing at SUSE with them, or how we integrated them into openSUSE. But first, we are going to give like a short overview about what Kata container actually is and how it works. So if you go to the Kata Containers website, you will see a phrase like this. It's a container runtime that provides stronger isolation by using hardware virtualization technologies. And then the sentence goes on and on with some more words, but this one is the most important one. And well, to show you what that means, let's first take a look at how containers normally work. So in the normal case, you have your host with the Linux kernel, and every container basically is just a single process which is isolated from the host system by utilizing things like cgroups, seccomp, AppAmmo or SE Linux, namespaces, and things like that. But still, they're all sharing the same kernel, they are all running on the same host, and so there is, well, it's not as well separated as it could be. In the Kata containers case, Kata adds another level of, or layer of security around that by including all, or by running all these containers inside a small virtual machine. So every container is a really tiny virtual machine with a separate kernel. Inside that virtual machine, also the containers are utilizing the standard security mechanisms that containers usually use, like namespaces and so on. But as the additional layer, you have the hardware virtualization, which is like isolating the system even more from the host system. And yeah, Dario will have some details about what additional security that actually provides.
Yes. So very quickly, as Ralph said, Kata Containers uses virtualization, adds virtualization to the picture of containers. So why why doing that? Why adding virtualization, and why not just let containers be well, containers? Yeah, well, if we think of a scenario where we have potentially untrusted code running inside your containers, then one reason would be attack surface. Meaning that in a standard container setup, then the attack surface from inside the container to the host, if your malicious code running the container wants to attack the host, the attack surface is the one it's the interface, the syscode interface of the shared kernel with all its variants, which is huge. Of course, you can restrict it, but it's still shared kernel between among all the containers. While on the other end, if you have virtualization, then the attack surface is the one of the hypervisor. And even if you add to that the device model, basically, so all the abstractions that you need to create virtual devices, then the attack surface is still smaller. Then another point, defense in depth, meaning that to actually escape, with virtualization in the picture, to actually escape, if something running inside a Kata container wants to escape and do harm at the host level, it needs to escape two layers, containers and virtualization. And so as a matter of fact, what you get is improved isolation, as Ralph has already said. Meaning that, for example, even if someone manages to escape from the container, for example, and manages, for example, to exploit one vulnerability to crash the host, if you are running in a standard container setup, then it can actually crash the host and cause denial of service for all the other containers running there. While on the other hand, with virtualization, and so in Kata container setup, it can only crash. It's the virtual machine where it's running inside. And of course, this all comes at a price in terms of overhead, mostly CPU and memory overhead. And of course, we want for these to be as small as possible, even at the price of having reduced functionality with respect to as compared to traditional virtualization, because we don't need, for example, all the features. And we want, in fact, a small and fast kernel inside our own little VMs. And we also want a small and fast virtual machine monitor. And to do that, you basically configure the kernel so that it's tiny and little, and it only includes all the features that you need. And as far as machine monitors goes, you can use QEMU, which is the most common choice in traditional virtualization, but you can also use others which have different properties. And in openSUSE right now, as you will see later in our demo, we are using a smaller kernel than the one we provided by default. It's called KVS Small. It's a flavor of our kernel, although this should be regarded as a temporary solution, and we are investigating what would be the best long-term approach and solution. And for virtual machine monitor, right now you would get, if you use Kata Containers on openSUSE, you would get them running and using just plain standard QEMU. But again, here we are investigating better approaches, including Firecracker and including using QEMU with micro VM, which is something being actively developed these days. And I'm done.
Yeah, another feature of Kata Containers is that it's actually implementing the OCI specifications. So the advantage of that is that you can just replace your current runtime, in most cases run C, I guess, with Kata Containers, and all the tools that use run C will seamlessly continue to work with Kata Containers, but now leveraging the enhanced security. So you could just use Podman or Kubernetes with Cryo or even Docker and run Kata Containers using that without any, with just very small changes in how you use it. Important to mention what Kata Containers is not as well. It's not like a tool to run your normal virtual machine workloads inside Kubernetes or something. It's really about running containers. This is a small overview about the internals of Kata Containers. Basically, what's outside the box here could also be Podman, for example. Podman would call conman, which calls Kata runtime in the same manner as it would call run C. Kata runtime then will create the sandbox, the virtual machine, basically calling QEMU and talking to it via its management socket. And that will launch the virtual machine. That virtual machine image will as the single process, start the Kata agent. And that is then being used or talked to in a gRPC on a vSOC interface or on a virtual virt.io serial interface. That depends a little on the configuration to launch the containers inside the sandbox. And also the standard in and standard out, and these things are going via that vSOC thing. I think that should be enough for how the architecture looks like. This is basically summarizing it. Some words about how storage is implemented in Kata Containers, like if you the container root file system and volumes that you attach to your container, they are currently shared or injected into the container using the 9pfs file system. And I don't know if you ever used 9pfs. It has some performance issues. It's pretty slow. And there's work underway to replace that with the virt.io, which is, I think, recently landed into the kernel in 5.4 or 5.3, I'm not entirely sure. And also virt.io support is going to be part of the next QEMU release, and that will give much better performance than 9pfs. Some words about how you could use it if you use openSUSE. If you're on Tumbleweed, it's just easy. You can just install it. It's available in the standard repositories. Just call super install Kata Containers, and it will be there. For other distributions, we are providing it via the Devil Cubic project in the Open Build service, and it's there for Leap, various releases, and also for SLES. If you want to play around with that, there are two packages actually. There's the Kata Containers package, which contains the runtime, and then there's the other package which contains the specific kernel and init.rd for running the virtual machine. So now for some short demo. First thing I'm going to show is how to use it with Podman. And as I didn't sacrifice enough chicken for the demo god, I'm just playing a video. This one. I hope that's big enough for everyone to see. Yeah, just to prove this is a tumbleweed system which has the Kata Containers packages installed. It's basically the latest packages. There's one small configuration change that needs to be made if you want to run Kata Containers rootless on your with your normal user instead of root. You would need in the local configuration to adapt the temp directory to your user's run path, and additionally, there's the need to enable the runtime of Kata to be a supported runtime for Podman. There's the section runtimes in the libpod.conf, which lists all the available runtimes, and the standard one is run C. This Kata runtime thing needs to be added so that Podman can find the runtime. If the setting is left empty, it will look into the standard paths like user bin for the binary. Otherwise, you could also specify a concrete path where it should be looking. Yeah, and then basically for this demo, actually, I prepared a small Nextcloud image and configured it. So I will just launch it now, which is already configured, and you can now see that if you run a command in that container, so the container is launched, and now I run the unit name -a command there, and you see that it's running the KVM small kernel, which is different from the host kernel, just as a proof that it's actually using a different kernel and virtualization. Yeah, and here you see the application in action. I guess, yeah, most of you have seen this. Just to take a look at how it looks from the processes, just looking for the Conmon process, seeing what it launches, and taking a look at its child processes to see the whole architecture in action. So you see that Conmon is talking to Kata shim, which is like talking to the agent inside the virtual machine and collecting standard in and standard out and processing the signals of the container. And there you see the virtual machine running inside QEMU. That's basically it for the Podman demo. I'm not sure, do we have enough time for? Okay, yeah, then let's try the other one. I have also prepared something to show how to run it in Kubernetes. Basically, this Kubernetes cluster I'm using is based on Cubic, so it's just a simple one with just a single master and 3 workers. All nodes need to have the packages installed, of course. There's a small configuration change that needs to be made to the cryo configuration, similar to what we've done for the libpodconf. You need to enable the runtime. It looks slightly different here, but it's essentially the same. You just define that you have an additional runtime. In this case, the runtime will be called Kata runtime, and we'll also look for that binary. Then you need to restart cryo and also the kubelet service to pick up the changes. You need to do all that on all nodes of the cluster, of course, because you don't know where your workload is going to be scheduled. And then in this case, you need to define a new runtime class for your cluster. Runtime classes is a feature that got introduced in some not too old version of Kubernetes, where you can define alternative runtimes so that you can switch your workload to, like, you use a different runtime. You can have like one container or one pod using the standard runC runtime and another one using Kata in parallel on the same machine, for example. And to do that, you need to have this runtime class defined and upload it to the cluster. I skip a bit here just to, now there's a runtime class called Kata. And basically, if you want to run an application, this one is a sample application from the Kubernetes repository, which is just a very simple thing. It launches 3 Redis nodes and a simple PHP application, which acts like a guest book. And in this case, I run the Redis on the bare metal nodes, or using the standard runC runtime. And for the front-end application, the PHP thing, I decided to put it into the runtime class Kata. You can see it here. That's all you need to change in the YAML file to have it run using Kata instead of the standard runtime. So basically, this application just needs to be loaded into the cluster, and then it needs to need to wait until it's running. I'll skip over this. And basically, this is also proving that the application is actually running. And here I execute the same command as earlier for Podman inside the container, and you can see that it's also running in a different kernel than the host. I think that's basically it. Are there questions? Oh yeah, quite a few.
What about startup time?
Sorry?
What about startup time?
Yeah, it's of course a little longer, but the project is trying to optimize for that, and that's why they reduced the initRD to the absolute minimum. Like, you need, the initRD basically just contains the Kata agent, and it boots. In our case, it's like I'd say 2.5 seconds for booting up the virtual machine. But it can be made even faster.
That's what we were saying about using smaller and tailored kernel, and also special purpose virtual machine monitor. Right now what you get is, yes, a smaller kernel, but a pretty standard QEMU as a machine monitor. While we would want to use either a different machine monitor than QEMU, or, as I said, QEMU with configured in a special way, which would reduce a lot the startup time, for example, and also the memory footprint. And this is something which is not currently there yet if you install the openSUSE packages, but it will when it's ready.
So, hi there. I was about to ask the same question, and the follow-up was like, have you tried some sort of VM reuse for a different container, or is Kata always starting from scratch?
Currently, it's always starting from scratch. So I think there was once an idea to just start the virtual machines from a snapshot. So like taking a running machine, taking a snapshot and cloning that and then starting it up again. I don't know if that's still an idea or how that really worked out. But things like that can be done. But there is currently no like, for example, pre-start or something, like keeping a couple of virtual machines running in the background or something. That's not there.
I think, I'm not sure, but I think there are things, so like doing things in parallel, so like preparing the storage while the virtual machine is booting, so to parallel things.
It's for example, it's booting up a very small machine, and later on adding memory to it via hot plugging and hot plugging the network device when the kernel is already booting, and things like that.
Okay, we're out of time. Thank you very much.
Cool, thanks.